Okay, geometry kids, this is Trig Part 2. So kind of just building on what we talked about yesterday or what we talked about last time. Remember talking about trig and that in right triangles, things can happen to where two sides are always going to be in that same ratio depending on what the angle measure is. So now we're trying to kind of set up and kind of be able to solve for any angle, any side, any time in a right triangle. So that's kind of our goal here. Be able to solve for side lengths and angle measures in a triangle. So remember, SOHCAHTOA, wouldn't be a bad idea to write this on assignments, write this on quizzes, just so you kind of remember what it means. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, just keeping those three things straight and solving for it. So figuring out the sine of A, so the sine of A, so A is what we're looking at. Sine, remember, is opposite over hypotenuse. So from here, the opposite side is going to be 12, and the hypotenuse is going to be 20. Hypotenuse is always hypotenuse. Cosine is going to be the adjacent side over the hypotenuse, so that's going to be 16 over 20. And again, simplify. You can simplify the fractions. I mean, this can be 3 over 5. This can be 4 over 5, and so on. Tangent of A, remember, is going to be opposite over adjacent, so that's going to be 12 over 16. So that's going to simplify, that would be 3/4. Okay, so there it is, there it is, there it is. There's your sine, cosine, and tangent for this triangle. So remember, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So figure out what BC is. So BC is this side right here. Let's go purple. So from this angle, I've got this side and this side. So this would be my opposite side. This is going to be my adjacent side. I know that because here's the right triangle. That makes this hypotenuse. And for right now, I don't care about the hypotenuse. That does not help me at all. So I've got opposite and adjacent. So take that as tangent, and let's see what we got. So I've got the tangent of 64, and that's going to be equal to, the opposite side, x over 13. So remember, make sure that the calculator is in degree mode. So it needs to be in degree mode. So now tangent of 64 is going to be 2.0503, that's a 5, sorry, equals x over 13. So take your answer times 13, so it's going to be 26.65 equals x. So that means this side is going to be about 26.65. Okay, so that's all I got for that. Moving on. So now figuring out what x is, let's take a look. So here's the angle I want. So from here, that's going to be opposite. This one's going to be the adjacent. Long side is going to be hypotenuse, but I don't really care about that. What I do care about is that I'm going to use tangent here. So I want tangent of 47 equal to 19 over x. Okay, now here's a little bit tricky part because the tangent of 47 is going to be 1.072. Now, I can't just multiply by 19. Multiplying by 19 doesn't help me, okay? I could divide both sides by 19, but that wouldn't help me either because that would make the x still in the denominator. So what I need to do now is multiply both sides by x, okay? Now, here's what that does. On the right, it cancels out the x's. On the left, I get 1.072x equals 19. So now I want to divide by 1.072 on both sides. So x is going to be equal to 19 over 1.072. Okay, let me break this down for you in a different way. Oops. So I've got the tangent of 47 equal to 19 over x. So here's kind of essentially what happens. All right, I multiply both sides by x right here. Then I divided by 1.072, which was what tangent of 47 was. So then I ended up with 19 over that. So essentially all that happens is these two switch places. So kind of a shortcut way is when you have a situation like this where your x is in the denominator, those two switch. So I can take 19 divided by the tangent of 47, and I get x to be 17.72. So if x is in the denominator, just switch them. So figure out x here. Okay, so let's look. What am I dealing with here? Well, 61's here. That's important. Over there, that's going to be my opposite side. This is not going to be adjacent because it's away from, it's the longest side. It's away from the 90 degrees. Hypotenuse is always the hypotenuse is always the hypotenuse. All right, so opposite hypotenuse, that means it's sine time. So looking at what we're dealing with here, that's going to be sine of 61 equals 22 over x. Now, remember what just happened on the last one, all right? I can multiply both sides by x. So that gives me x times sine of 61 equals 22. Divide by sine of 61. So x equals 22 divided by the sine of 61. If I put that in a calculator and actually crank out a number, I'm going to get 25.15. There's my answer. Which should make sense. It should be longer than 22 because it's a hypotenuse. Okay, so if you want to figure out an angle, you have to use inverse sine, inverse cosine, inverse tangent. And it looks like this, and it looks just like that on a calculator too. A lot of times all you have to do is push second and that same button, and you'll get your answer. So you want to figure out the measure of angle A. So this is angle A. So what am I dealing with here? So I've got opposite, I've got hypotenuse. So that's op, that's hype. So I've got sine there. So that's going to be 18 over 27. So now getting rid of this is kind of like doing the opposite of what's there. So it's kind of like if you had addition, you'd take subtraction. If you had multiplication, you would take division. If you had square, you'd take square root. Same idea is that instead of sine of A equals 18 over 27, and again, it doesn't matter. You could simplify that, don't simplify that, I don't care. I'm going to take the sine inverse of both those sides. So sine inverse and sine cancel out. I'm left with just A. That's going to be sine inverse of 18 over 27. So what I get when I do that is 41.81 degrees. So that's how big A is. So for number 6, figure out the measure of angle T. So angle T is right here. Switch colors. Angle T is right here. I got boom, I got boom. So that's opposite. This is going to be adjacent. So that's going to be opposite adjacent. That means it's tangent. So the tangent of T is going to be equal to 8 over 12. So now to get rid of that, I'm going to take the tangent inverse of both sides. So that's going to cancel out, and we'll be left with angle T, tangent inverse of 8 over 12. So when I do that, T is going to be equal to 33.7. So that's how big that angle is. So if you want me to show you how to do it on the calculator, please do. I'd be more than happy to help you with anything that you need to see. All right, so I got to find all the missing parts of the triangle. So this is kind of what I'm talking about. Figure out all the angles, figure out all the sides. So let's start off simple here. Let's figure out FH, this length right here. Okay, so it's simple. It's still a right triangle, which means I can still use Pythagorean theorem. Oops, wrong button. You know what? Forget that. Pythagorean theorem. So this is 13, this is 5. I need to figure out b. So that's going to be 5 squared plus b squared equals 13 squared. So that's 25 plus b squared equals 169. So subtract 25, subtract 25. 144. So b is going to equal 12. So b equals 12. So this length is 12. Okay. So now part 2 of this is I got to figure out one of the angles. If I figure out one of the angles, I can figure out both of the angles because guess what? It's still a triangle and it's got to add up to 180. So if I look at f, I'll go opposite over hypotenuse. So the sine of f is going to be equal to 5 over 13. So get rid of this by taking sine inverse. So f is going to be equal to the sine inverse of 5 over 13. So angle F is going to be equal to 22.62 degrees. So that's how big F is. To figure out G, excuse me, I'm going to take 90 minus 22.62. Now, why did I take 90? Where did this 90 come from? Well, the entire triangle is 180 degrees, right? I know this angle is already 90 degrees, so I take minus 90. That leaves me 90 minus 22.62. When I subtract that, I get 67.38. So that's how big angle G is. So, figured out this third side, figured out this angle, figured out this angle. That's all the missing pieces. All right, so take your time. We're starting to put together everything you know about right triangles and using them all. Come talk to me with questions. Take your time and work through this. See you soon.